So today we're taking a look at the gas laws, and I guess you all got this on the PowerPoint presentation. This is the main plan. We are going to be using this kind of apparatus to take a look at Boyle's law, and we're going to find the volume of a Erlenmeyer flask to test Avogadro's law and Charles' law. So this is the plan. We have to find the volume of this. Let me show you. So we need the volume of this flask. For Avogadro's law, the plan is that this is going to be completely filled up with gas molecules at certain temperature, and the volume limit is set up by this. Okay, so that's the volume limit. You have to fill up this completely to that level, and then write that volume. For Charles' law, there is a small difference. We need to adapt this hose and this part here, and then the volume will be slightly different because we have the tubing and some of this volume is not there anymore. It's going to be used by the rubber stopper. So we have to find those volumes for those gas laws. For Boyle's law, we have built this apparatus here, and we have marked some milliliter labels there because this was a little spent. So this is a 10 milliliter syringe, and it takes more than 10 milliliters. So we have marked it up to 12. And depending on the temperature on the day you are doing the experiment, the air that is trapped has a certain volume. If you press down the plunger, then there is a restoring force setting the volume back to where it was. Okay. So the idea is that we have to apply a force to that plunger. To do that, we need to know the mass of some weights that we're going to put there. So let's do that first. Let's find the mass of the weight that we're going to be using. For Boyle's law, we're going to use this as weights, significance. They are not all exactly the same mass. So we're going to see what mass they are first. Okay, if everyone can see that. So weight number 1. 1 pound and 1/2 ounce. And then when we add the other weight, 2 pounds, okay, 2 pounds, 2.3 ounces. So we record that. So when we are doing Boyle's law, we are going to use 1 pound, 0.5 ounces. And then when we put the 2 cans, we're going to use 2 pounds and 2.3 ounces. The reason why we're doing that is because we want to use the unit of mass, that is pounds, so that we can use pounds per square inch as a pressure. Okay. So this is taken care of. We have the mass of the weights that we're going to use for Boyle's law. Next thing we need is we need to find the volume of this up to that level. because we are going to cover this, and that's the volume that will be occupied by the molecules. So to do that, we fill it up with water. So we have here the water for the experiment, and the water is cold. It still has some ice on it. This is to make sure that the water we are using is exactly 0 degrees Celsius. So we're adding more ice. We don't need to measure the temperature of this water as long as there is ice melting in the water. The temperature is going to be 0 degrees Celsius. And that is the main idea. We're going to use 0 degrees Celsius as the low temperature for shelf flow. And we're going to use this water here that is very hot at about 95 degrees. Let me try it.
Degrees Celsius.
So it's getting to 95. We're gonna add a little bit more water to make sure we have enough. The volume of the water should be about 1/2 of the beaker because we have to put this in there. If we put more water, it's going to spill over. So let's find the volume first. I see that the water is not very visible in the screen, so we're going to pull a bag of tricks here, and okay, we're going to give some color to the water, make sure we can see it. Okay, so now the water has some color, and it will be visible in the camera. Alright. Now what we have to do is we have to find the volume of this. To find the volume, we have to fill it up. Okay? And we need to make sure that the volume is exactly up to the top. So that will be for Avogadro's law. The Avogadro's law volume will be exactly to the tip. Okay. So that's for Avogadro's law volume. Then we waited and we have like 156.5, almost 157. To make it exact, we're going to just record the data the way it is. So the Avogadro's law volume will be 156.5 milliliters. And now what we want to do is we want to fill it up for the Charles law volume. The Charles law volume would be slightly different. So some volume has been used up by the rubber stopper, some volume went up, and then we just need to fill this up to the level. So fill up the tubing. Okay, so now the tubing is filled up. We just empty it again, zero, empty all the volume. So this is our Charles law volume. It's a little larger than the Avogadro's law volume. And what we get there is 157, almost 158. We're going to record it exactly as 157.5. 157.5 is our volume in milliliters for the Charles law experiment. Okay, so now we have the mass that we're going to use for um, Boyle's law. We have the mass we are going to use for the second Boyle's law. And what we do with these masses is, if you have a mass of 156.5 milliliters, grams, that's the same in milliliters, because the density of water is 1 gram per milliliter. So every time you recorded the mass in grams in there, we just change the label to milliliters because it's an equivalent quantity. Okay, let's move on. Okay, so now what we do is we want to heat up this. So now, right now, what we have here, we have some air. We got rid of all the water we could. Whatever is there is going to evaporate anyway. So we have here the volume, Charles law volume, 157.5 milliliters of air trapped in this tubing and on this container. Now we put this in here, which is 95 degrees Celsius. Okay, and I don't know if as you can see there is bubbling in there. So those bubbles are coming out through there because the air, the 157.5 milliliters of air that we put in there are expanding. Now they do not fit into the 157.5 milliliter volume. The excess volume has to get out, and the way it gets out is by bubbling out through the tube. Okay, so when the bubbling has stopped, you can move this a little to make sure it's really done. Okay, it wasn't done yet. Okay, when the bubbling stops, that means that the volume of the air has reached its maximum. So that's the volume of the air at a temperature of 95 degrees Celsius, which is the temperature we set that water to. Okay. Now this is air at 95 degrees. When we put it in here, in the ice water, the air is now going to be air at 0 degrees. And because the air is now at 0 degrees, the volume contracted. When the volume becomes smaller, the volume has to be occupied by some fluid, which is this fluid. Okay, so the volume that we have here is the volume of air at 0 degrees. The volume that we have here is the volume that we have to subtract to find that volume. So the entire volume is 157.5 milliliters. At the volume of cold air will be 157.5 milliliters minus whatever is here. So let's see what's in there. Okay, so we got 41 milliliters of water symphony. We have 41 milliliters of water that went into this flask. Okay, now for Avogadro's flow, what we do is we need to make sure this is almost dry, as dry as it can be. Okay, so now everything is gone, it's dry. And this is what we're going to do. We're going to take a sample of what is practically acetone. So this is the only acetone we could find. It has some coloring, it has some ingredients, but whatever other ingredients has is a very small percentage of what this bottle contains. So this bottle is nearly 100% acetone, the nail polish remover. Okay, now we have heated up the flask, and all of the liquid that was in there has evaporated, completely empty now. And what we're going to do is we're going to put some of this acetone in here. You didn't need that much. Okay, just a small amount of acetone. The amount that will remain at the end will be a lot smaller than that. The reason why we don't need to measure the amount that we put in first is because the excess is going to just evaporate. So now we seal it with aluminum foil. And then we punch a hole. So this is what is going to happen. We put some liquid in there. The liquid is going to vaporize. The pressure is going to go up inside the container. Some of the molecules are going to get out, and when the pressure inside the container is equal to the barometric pressure, the outside pressure, then we are going to have an equilibrium system. Then we cool this down, and whatever remains here is the number of molecules that were here at the temperature of the flask at 1 atmosphere of pressure. Okay, so we just put this to cook, and we leave it aside. So now let's move on to Boyle's law. So for Boyle's law, this is a little tricky. We set up our apparatus. And now we take the can of sardines that weighs 1 pound and a half ounce. And to compress this volume of air that at the moment is about 11 and a quarter. So this is what we got here. We have markings are not very accurate, but they are like 1 milliliter, 2 milliliters, and then division between half a milliliter. So we can see that the plunger is between 11 and 11.5, almost halfway. So we're going to take it as being 11.25 milliliters. That will be our volume initially before any force is applied. Now we applied some force. This is a little tricky. We have to balance this. Okay. And then let the restoring force do the trick. Okay, so we have 11.25, and now I think this is stopped already. So that's 8, 9, 8.5, something between 8.5 and 9. 8.5 and 9. We're going to take it as being 8 and 3/4 of a milliliter, 8.75, so that we just do it as accurate as we can. So we have 8.75 going from 11.25 milliliters. Now we have the next can. The mass now is going to be uh, 2 pounds, 2.3 ounces. Okay. Okay. So I guess this is equilibrated, and the plunger is not going to move over anymore. So that's 7. That's 7.5. It's closer to 7 than it is to 6.5. We could take it as 7 point. We could say 7.1, just so that we are as accurate as we can. So we're gonna assume this is 7.10. 7.10 milliliters. That's when we add 1 pound and 0.5 ounces, and this one is 2 pounds and 2.3 ounces. Okay, so now we have the data that we need for Boyle's law. We have the data that we need for Charles' law. The only remaining now is Avogadro's law. So carefully remove this, and you see the plunger goes up when the force is removed until it gets to 11.25 milliliters. You press it again and release the force, then it goes back to the initial volume. Okay, so while we wait for Avogadro's law experiment to end, okay, this is already vaporizing quite well, not much remaining in there. We need another piece of information for Boyle's law. We are going to be using the units of pressure of pounds of force per square inch. In order to do that, we need to know the area of this plunger. Find the area of this plunger. And we take a caliper and we measure the diameter of the syringe, the internal diameter, okay, also called the bore diameter. So this is a little bit more than a half an inch. I don't know if it's visible there. 9/16 of an inch, more than 1/2 of an inch. Okay, so we write the diameter as being 9/16 of an inch. Okay, so the bore diameter of the plunger that we were using is 9/16 of an inch. Now all that we need is the Avogadro stroke pad. So we take out this. This is the idea. Right now, you have all of the molecules that can occupy the volume at that temperature and the barometric pressure this day. When you transfer this to the cold water bath, you dry the flask to make sure whatever you have here is only the material that condenses. So it's only a small amount of liquid here condensed on the walls of the flask. Some droplets, and then you weigh it. So now, according to that, the third mass of the flask, we have like 0.3 grams in there. Okay, so we got all the data that we need, and we're going to take a little break while we set up the board. So 5-minute break, everyone.